Hello students, welcome to CM Hub, where you, me and chemistry connect with each other. This platform is a gateway for mastering chemistry. Let us work it out differently. We will master chemistry by using problem-solving methods. We will learn the concepts of stoichiometry today with respect to oxidation state and connecting the number of electrons involved in the reaction with the Faradays. This is one question which was asked in NEET 2024. Let us first understand the problem. What is given in list 1, what is given in list 2. In list 1, we are given a reactant and a product, and in list 2, we are given the number of Faradays involved. What is the connection between these two, list 1 and list 2? List 1 says that the reaction is a redox reaction and the number of electrons that are involved in it will help us to know the number of Faradays that are utilized in the conversion. What is it that you need to know to solve this problem? The first thing that you need to know is with respect to oxidation state. What is meant by oxidation state? It is defined as the charge which the atom is said to have acquired when it either gains electrons or loses electrons or unequally shares electrons. Now we know in a redox reaction, electrons are either gained or lost. Oxidation is a process where electrons are lost. Reduction is a process where electrons are gained. Now, how do we find the oxidation state? Finding the oxidation state. This is the second thing that you need to know. There are certain rules which you have to memorize. You have already learned this in your regular classes, but this is again a recap and helps us in understanding the problem-solving methodologies. Rule 1. An atom in its elemental form or molecular form exhibits an oxidation state 0. All alkali metals in their compounds exhibit +1 oxidation state. Alkali and earth metals exhibit +2 oxidation state in their compounds. Hydrogen exhibits +1 oxidation state when it is bonded to nonmetals and -1 oxidation state when it is bonded to metals. Oxygen exhibits an oxidation state of -2 when it is referred as an oxide, -1 in peroxides and -1/2 in superoxides. It also exhibits positive oxidation state but only when bound to fluorine. Halogens are mostly -1 when they are regarded as halides or when they are more electronegative. However, when they are bound to more electronegative elements, they exhibit positive oxidation states. Fluorine in all its compounds is always -1. But the two important rules that you need to remember is the sum of the oxidation state is always equal to 0 in a neutral molecule, and the sum of the oxidation state is equal to the charge on the species in a charged species. So taking these clues, taking these important rules into consideration, we'll go into the problem. Now what is the third thing that you need to know? The third thing that you need to know is the change in oxidation state. In what way will the change in oxidation state help us to solve this problem? You need to find the oxidation state on the reactant side. You need to find the oxidation state on the product side, and the difference in this oxidation state will give us the number of electrons involved in that redox reaction. Always go with the calculation as higher oxidation state minus lower oxidation state. Higher oxidation state corresponds to the value along with the sign notation plus or minus, Lower oxidation state also same, the magnitude with the sign notation. So if I have -1 and +1 is higher oxidation state, -1 is lower oxidation state. Number of electrons involved in the redox reaction is higher oxidation state minus lower oxidation state. So these are the three important areas that you have to know to solve problems of this particular category. But the fourth important specifically to this problem is what is the relationship between Faradays and these electrons. I'll put that as a fourth one, but the important one in this problem. 1 mole of electrons always carry a charge equivalent to 1 Faraday. That implies 6.023 into 10 to the power of 23 electrons carry a charge equivalent to 1 Faraday. So if in a reaction 1 mole of electrons are involved, it represents the charge equivalent to 1 Faraday. 2 moles of electrons are involved implies it refers to 2 Faradays. N moles of electrons are involved, it implies N Faradays. Now we'll solve the first one where H2O is converted into O2. H2O gives rise to O2. Let us first balance oxygen. There is only one oxygen on the reactant side. There are 2 oxygens on the product side. So I'll make it as 2H2O gives O2. Temporarily, I am not bothered about the second part of the reaction. That is, what are the other byproducts that are involved. I am only looking at with respect to oxygen. So now oxygen's oxidation state, because it is regarded as an oxide, it is -2. 2 into -2, -4 is the total oxidation state of oxygen on the reactant side. Now on the product side, oxygen is in its molecular form. The oxidation state of an element in its molecular form is 0. So on the product side it is 0. -4 and 0, which one is the higher oxidation state? 0. So now use the formula higher oxidation state minus of lower oxidation state. That is equal to +4. Take only the magnitude. That implies 4 moles of electrons are involved for every 2 moles of water, which converts into oxygen. But here the question is asked only with respect to 1 mole. So 2 moles of water requires 4 moles of electrons, that is equal to 4 Faraday. Therefore 1 mole of water requires 2 moles of electrons, that implies it is equal to 2 Faraday. So for first one the answer will be 2 Faraday. Now let us look at the second one. 1 mole of MnO4 minus to Mn2 plus. NO4 minus to Mn plus 2. So here 1 manganese both are balanced. Now check the oxidation state. The sum of the oxidation state is equal to charge. So x plus 4 into -2 is equal to -1. So x minus 8 is equal to -1 implies x is equal to +7. So oxidation state of manganese on the reactant side is +7. 1 manganese is there, 1 into +7, +7. Already the oxidation state of manganese on the product side is directly given because manganese is in +2 oxidation state. So +7 is changing to +2. +7 to +2, what is the change in oxidation state? Higher oxidation state minus lower oxidation state 5. That implies 5 moles of electrons are involved. So 1 mole of MnO4 minus requires 5 moles of electron, that is equal to 5 Faraday. 1 mole of MnO4 minus therefore requires 5 Faradays. Now third one is 1.5 mole of calcium from molten calcium chloride. Now let us look at the third one. 1.5 mole of calcium from calcium chloride. So CaCl2 gives rise to Ca. This is alkaline earth metal. Oxidation state of alkaline earth metal in all its compounds is +2. plus 2 is changing to 0. So higher oxidation state is 2, lower oxidation state is 0, 2. That implies for every 1 mole of CaCl2 converting into calcium, I require 2 moles of electrons, that is equal to 2 Faradays. But what is asked? 1.5 mole of calcium. So 1.5 mole of calcium chloride to convert into calcium requires 1.5 into 2 mole of electron, that is equal to 3 Faraday. Now let us look at the last one. 1 mole of FeO to Fe2O3. Same, let us first balance only iron part. 2 FeO gives oxidation state of iron in this is plus 2. Oxidation state of iron here is plus 3. 2 into plus 2 plus 4. 2 into plus 3 plus 6. That implies plus 4 total oxidation state is changing to plus 6. Therefore, number of electrons involved is equal to higher oxidation state 6 minus lower oxidation state 4, that is equal to 2. So 2 mole of FeO to convert into Fe2O3 requires 2 moles of electron, that is equal to 2 Faraday. So 1 mole of FeO to convert into Fe2O3 requires 1 mole of electron, that is equal to 1 Faraday. The answer is D will be 1. So we can take the options as A is 2, B is 4, C is 1 and D is 3. You check for the answer option which is there in the given ones with respect to A2, B4, C1, D3. So to solve this category of problems, on the whole you require major 4 concepts. 1, you need to know oxidation state. Second, you need to find the oxidation state by using the 9 rules. And third, you need to know the change in oxidation state to find the number of electrons involved. How will you go for it? We go for higher oxidation state minus lower oxidation state. And for this problem to get solved, you need to know the relationship between the number of moles of electrons and Faraday. 1 mole of electron carry a charge equivalent to 1 Faraday. That's all for it today. We'll meet again, we'll connect again in the next episode with another problem and another concept. If you have liked it, subscribe to my channel CM Hub. Take care, bye bye.